let's get started. Welcome to today's last session. Today's session is brought to you by Vita Volunteer, an organization that positively impacts the quality of life in underserved communities. We're so honored to have Dr. Suhan He, who is a faculty member in the Department of Emergency Medicine and Lab of Computer Science at Massachusetts General Hospital, as well as an instructor of medicine at Harvard Medical School. During his career, he has co-founded a nationally recognized nonprofit and launched a company supplying novel scientific technology worldwide. His work has been featured in numerous publications such as Fast Company, The Verge, Nature, Time, and Forbes. Please give it up for Dr. He.
Thank you. All right, let me pull up the slides and, okay, share my screen. Here we go. Can anyone see my slides?
Yes.
Excellent. All right. First of all, thank you for being here, everyone. It's great to wrap up the day with some technical learning around healthcare data analytics and machine learning. This is a talk that is something that's been really exciting for me to see, in that folks who are looking to careers in medicine are really taking interest in this idea that, when we take care of patients and we see patients in the ER like I do, we also can apply the modern tools that we have every single day, like stethoscopes, right? And apply them to new challenges and opportunities. And that's really exciting for me to see, because I was there once. I was a student and kind of a computer dork at the time, and really thought about how we could use these new amazing tools. And now that I'm here in the seat, taking care of patients in the ER, I still think about the same problems every day. I work as an emergency physician, but I also work in the lab of computer science, and really think about, wow, we have this amazing thing called data analytics. The hospital installed electronic medical records about 8 years ago. And subsequent to that, we've had a deluge of data. And one of the biggest issues we have is, how do we interpret all that data? How do we use the data to make every single day a little bit more pleasant for patients, whether that's decreasing wait times, make sure that patients who are the sickest get seen first, make sure that patient experiences get better. And so it's really exciting to me to see that there's so much energy around this whole topic around data analytics and AI and machine learning. So with that, I'll dive into it, and we will have a lot of questions available at the end. So first and foremost, how do all these things relate, right? What is data science versus AI versus machine learning? These seem to be broad definitions. Well, it turns out that data science is just this organizing large amounts of data. And I put that under the category of digital health, right? When you have applications, when you have electronic medical records, you basically end up with a data science problem, because you have so much data collected digitally. And when you have this amount of data, the only approach that you could take is really through AI and machine learning and expert systems, instead of traditional statistical approaches like Fisher t-tests, where you're trying to separate groups from each other. Because every piece of data isn't just one thing. It's 20 pieces of information, right? I am Dr. He, I am a patient, I am a doctor, I am a computer scientist, I am an ER physician, I am a speaker, right? All these can be true at the same time. And because of that, we have to think about people and pieces of data and patients and physicians and relations between each other in much more complicated ways. And these modern tools of AI and machine learning allow us to do that. So machine learning, let's think about just the very basics of what is the difference between traditional programming and machine learning. So in traditional programming, what happens is I sit there and write a line of code, and we say, take this A variable, if and then, and specify a specific rule. That if A is greater than 1, then we want to discharge the patient, okay? That is traditional programming. So it's very logically based. Machine learning is not logically based, and why that's so exciting, because really, every single day when you are trying to get through the day, I want a cup of coffee. You're trying to say, I want some cup of coffee. I might want coffee with milk or sugar, and I would like it hot or cold, or with a little bit of chocolate milk. Right? So it has a lot more meaning than just one specific thing that means one thing specifically. And that's what traditional programming does. Machine learning allows you to have a wider scope to say, I would like to feel better for my chest pain. And I don't always care how you do it, but I will say what the input and output is of what I want. and I can tell the machine to go and do it for me. And that's what's so exciting, is that the machine can write the rules, and it doesn't have to be one-on-one like in traditional programming. So because of that, we can do so many more interesting things that allow us to basically solve problems that we couldn't before. Now, there are a lot of issues, and this is the thing I always point to start off with, because I want to scare people a little bit, but I want students to understand the weight and gravity of these things. The Boeing 737 MAX was a famous story about AI gone wrong. It is a series of two airplane crashes that occurred in October 2018 and March 2019, where there were faulty sensors on brand new models of planes, and they were basically reading faulty information from the environment. Because of that, they were feeding into a machine learning system that was basically telling the machine to automatically move the nose based on the sensors. The pilots had no way to override it. The pilots didn't even know the system was in place, and they couldn't override it. And there was no human in the loop. And because of that, the planes crashed. They didn't know how to override it. They didn't know how to interact with it. And it's usually a classic example of when you have systems go wrong without the knowledge and involvement of human people. And so with that said, it's been a really exciting time too, and not just a really scary time, because in December of 2022, about 8 months ago, ChatGPT was released. And I find this to be the most exciting thing ever. My moniker for this is the logo for basically AI machine large language models, because as a society, I think we actually start to understand how powerful these two tools can be. And it's meant that we could do so many different things with neural networks and text predictors and agents. And actually, it's so many different things at once, right? The chatbots, the writing assistant, the content generator. And we can think about it in so many different ways. And so with that said, I think it's so exciting that especially a lot of students are using ChatGPT, right? I teach courses, I teach a master's program, and I actually encourage students to use it, even though that's not always what I think the standard company line has been. Because oftentimes I want my students to do really interesting things, including ChatGPT, write me an essay, help me do this assignment. Well, I actually challenge students to do more than that. It is, here's an essay. I want you to argue against the essay. And then I want you to make arguments against the essay itself that you argued against. So you could start to do second, third, fourth order derivative thinking that is so much more interesting. And I've seen that from a lot of students. And I suspect when we get to the Q&A and talk about this, you guys are all doing this too. And a lot of institutes are putting in policies around this. And I actually sit on one of these for the master's program. And I actually argue strongly that we should allow it, but it does mean you have to redo our entire curriculum. And it's been a really exciting time because of that, and something I think that is very exciting, but at the same time full of pitfalls. Academia has this question of, should we adopt or resist AI and ChatGPT and these kind of really new tools that we probably all know students are using, and I, in my opinion, should use. And the question we always have is, can AI actually be reliably detected? And this comes up a lot. The Department of Computer Science from University of Maryland actually put a paper out, asking, could it actually be reliably detected? And the answer is probably no. So with that said, basically, a lot of the responses to the new tools in the last few months has been, we should detect it and eliminate, just like plagiarizing, but truthfully, you cannot. And I would love to see is for students to take more interest in taking third, fourth, fifth order derivative thought and getting rid of the more manual labor of writing ideas down. So with that said, it really has made a big difference in medicine as well. There was an article, I think this was Fast Company, basically in an ER doctor who said, I use ChatGPT to diagnose my patients, which was a very bold thing to say without any sort of licensure agreements, because that is not totally allowed yet. And these sort of tools are highly, highly regulated. So what I say and what I encourage people to do is understand the tools, not just through how powerful they are and what they can do, but also the regulatory constraints around them. In medicine, we are very conservative, and we are not allowed to do all these things because it introduces bias, and algorithms do not think for people and don't necessarily solve problems. And it really matters that you understand how these tools work so we can properly care for patients. And one of the things I always give example of is that the state boards of health have this definition of what medicine is. It's something called good faith exams, where when you take care of a patient, you actually have to not only see them, you can't just plug them into a machine, but you really actually have to do a physical exam as well. It's something called a good faith exam that establishes medical care. And these machines have not been validated on the definition of medical care. And that is why, it's not totally allowed to say you're doing and you're using the machine to help you diagnose or help you understand these things. And what I tell students is to highly understand the regulatory constraints around it, because it is so important to see where the pitfalls lie. And let me give you an example of this. If you ask Midjourney, which is one of the modern AI tools, to generate the human anatomy, this is the kind of anatomy it gives you. It seems proper. It seems actually kind of correct if you look at it from an initial onset, but then you actually look a little more carefully. You're like, what is that thing in the hip? It makes no sense, right? It's got most of the skeleton right, but I'd be really curious on what people in the chat can tell me what other things are wrong with the anatomy, right? And this is a really good example of, it has a very superficial understanding oftentimes of anatomical features, but especially these image generators, but it is not built for accuracy yet, and it's not built for use in clinical environments. So that's why it's important for any students coming up and learning about these systems to really understand how they work. This is another example. It looks actually very accurate at first, but I think it has too many ribs. I don't think the ulnar radius are actually properly done, and I think it has 6 or 7 fingers. So that's another example of what happens when you generate these things, and we try to use them without really understanding the clinical context. And to be very, very clear, these are highly regulated and should not be deployed in a clinical environment. And let me give you a few more examples of why. There is a thing called the level of AI, which is used oftentimes in deployment of autonomous driving vehicles. So, if you have a Tesla, it has some automation in it, it can self-drive. Cruise, if you go to Phoenix or San Francisco, there are automated taxis that can help you get around. And there are levels of automation, just like we do for radiologists. And the example here is level 0, which is zero automation. You do everything manually by yourself without any automation, all the way to level 1 and 2, which is partial automation to help you, let's say, sort out which one should be seen first, or help you auto dictate and complete your notes, or detect nodules on the lung. That is similar to partial driving automation. There's analogies in what we do in medicine to this. So that goes all the way to level 5. And so with that said, what I hope I convince you is this stuff is really interesting and is really changing the way that we are approaching medicine and digital health and technology and approaches to medicine. And I want to dive a little bit into how does this stuff work, right? Because we want to learn and understand that. And my hope is that if you guys are taking away from this talk, that you guys should spend a lot of time diving into these things, especially as young career physicians and scientists who are going to be at the forefront of this in your careers. Now, this is an artificial neural network. There's a lot of definitions and words on this slide. I'm not going to go through every one of them, but I want you to look at this figure, which is what an artificial neural network looks like. You basically input information, and there's nodes, just like synapses in the brain. And there's outputs, which is the information you get out of it. They talk to each other, and they back propagate to each other. So I'll give an example of this. I want coffee. It will input that information, and it generates a cup of coffee, right? But then when I taste it, I'll say, need some more sugar, or maybe a little bit more milk. And that I will change. And the machine, that is the back propagation to take that information back to say, next time I ask for a cup of coffee, maybe it'll be different, right? It's a similar concept of the input of information, taking back that feedback and learning from that over and over and over again. And as you have more and more of these nodes and more of the layers, it becomes a more and more interesting artificial neural network, which is what allows a lot of the machine learning. Now, neural networks and deep learning, what's the difference? Deep learning is when you have lots of networks. A neural network is basically that network for the input, middle, and output layer. A deep learning layer is basically many, many, many of these. So you can get closer and closer to what the human brain does in terms of processing decision-making and patterns, which is what allows these modern systems to not be purely logic-based, but be much more in-depth. Now, the thing that has changed all this is something called attention and mechanisms and basically vector analysis. So basically, you take all those neural networks, right? It's basically one slice layers, and you turn them into geometric figures. So these are basically a way to understand it. And let me explain this a little bit more. Let's say a language model is similar to a neural network, what we just saw, and you want to predict the next thing that you say. So if I say I am or I feel, you're likely not going to say coffee. I am coffee. I am not coffee. But if I am tired, then I want coffee. That makes more sense, right? So that's what language models are essentially, are distributions of ideas that go next to each other. You predict the next word. And what's so interesting is that you can do the same for things that you see in medicine. So if I say I have a fever, you can plot that. And you could say, well, what happens when you have a fever? Potentially Tylenol or redness or cellulitis or pain or sepsis. Those are things we often see in the ER. If someone says, I have a fever, just like if I say, I have coffee, it may have some sugar or milk, right? So what was so interesting about this was there was a paper, I'm not going to go deep into this, in 2018 that basically described this attention mechanism to transform neural networks and the weights into a geometric figure. And so let me give you an example of this, is what we do in medicine. If you take a 3-language idea, I feel emoji sad, sanxi, which is in Chinese, sad, right? I feel sad, and an emoji character. You can't, oops, there we go. I feel sad. You can transform these things using Unicode, which is the underlying language of all English and Chinese and emoji, which underlines the characters in phones that allows you to communicate between different phones and computers. Translate them into UTC-16, which is the code. Now you start to see that it's all one language, right? And you can then transform them into vectors and a geometric thought, such as this is what someone looks like when they're expressing sadness in not just English and not just physicality, but also in heart rate numbers, 120, heart rate 120, sad, SAD, and a crying emoji versus you based on usual understanding of language. So this is what's interesting. It's not just necessarily language anymore, it's actually ideas. And we can do so many different things to better understand people and the way they express themselves. And that's what's so exciting to me. And it goes into a lot of different parts of it. I'm not going to go into that today, but I do want to express that this is a really exciting time, because you start to think about, can this do really interesting things like artificial general intelligence and all these things? Large language models are very superhuman in many respects and can do things like goal planning and short-term memory. If you install those things, the difference between a machine that can do those things and people starts to get really, really close. And you start to wonder, how close is it to a person, right? So with that said, that's kind of the main part of the talk. I want to give 2 quick plugs on this. And just the last part is that, for any students who are thinking about long-term doing interesting things, the plug I always say is continue to do interesting things in your career, whether it's tech stuff or digital stuff or tech, because it is so interesting. Learn to code. We have a program. You guys can reach out to me if you need to, and if you're interested. We would love to have folks who are interested in doing that. At the same time, if you're already doing interesting tech stuff, I want to talk to you, because I love hearing about the projects that a lot of students have, especially around technology and digital data. We do a lot of that, and I would love to kind of get that talent and excitement in. So shoot me an email. I put it here as well at Conduct Science, and so free to reach out to me. But I know we have a lot of questions, especially around the space, around careers and things you guys are doing. So I want to make sure that we are preserving a lot of time for that. So definitely let me know. And with that, I'll go to QA.
Okay, amazing. What an interesting presentation. If you saw all the emojis of the faces. I think everyone was just amazed by all the applications of AI since it's such a current and relevant topic. So to start off, someone asked, how do you utilize machine learning in clinical research?
Yeah. My big project right now is around emoji, actually. You should be surprised by that. So in 2019, I helped to publish the anatomical heart and lung emoji that's used on devices worldwide. So if you guys see it, use it because actually that gets tracked somehow. I have no idea how they track it, but it's really important to me because I actually have a whole talk about this. But basically, um, it makes me really angry that there isn't a stomach, liver, spine, kidney emoji. And I deeply feel that medicine and science is more representation on the emoji keyboard. That's part one. Part two is when you walk into a pediatrician's office and you see the smiley faces, right? Those are actually just emoji, but they're not linked to any sort of data behind it. So when you talk about patient-reported outcomes, so how do I feel after my knee procedure? It's really important that we're not just doing knee procedures, but that we're also doing making people feel better, that they can walk more, that they feel more connected to their family, that they can walk their dog and are happy, right? That's ultimately the goal we're doing in medicine. So we not only want to measure time to discharge after knee procedure, but do you feel better? And with that, we can do that with emoji and better characterizations of keyboards because it's digital technology, and then you can basically collect massive patient-reported outcomes. And then suddenly you have this really complicated machine learning problem of what do I usually say when I have pain versus how did I do after this really big knee procedure, knee replacement. So that's kind of my big area of focus right now. But certainly a lot of different areas are really interesting as well.
Oh, wow. I did not know that the happy faces in the pediatrician office is like not really connected to, the wide expanse of G. So that's really exciting to hear. And then you touched upon in your presentation about the really intricate neural networks. And someone asked, is AI basically the metal version of an organic brain? And could you clarify the similarities and differences between like a real brain and like the AI neural network? Yeah.
So you guys will learn this in medical school is when you look at the brain, it's really multiple components, right? You have the forebrain for executive thought, you have the optic tract for vision, you have the olfactory nerves for smell, you have reflexes that don't even go through the forebrain, they're just spinal reflexes that never enter the spinal columns. Sorry, the brain and just enter the spinal columns to do the reflex, right? That's why you take the reflex hammer and you'll learn all those networks. So, I mean, the human brain is a lot more than computers, right? We are thinking machines, but we are happy machines, but sometimes we're hungry machines. And sometimes we're not machines at all because we're organic. And the question is like, how do you define a machine? So I would say that, AI is an amazing tool. I don't think it's like sentient, or I don't think it's organic yet. It is to me a better approximation of reality, which is that when you ask someone, how are you today? It won't say yes or no. It'll say, great, let's think about all the different possibilities. And that's really human. And I think a better way, frankly, to program ideas, because, we're language models. We are people that uses language with some ambiguity in language. And so that I think has been such an important update to machines, not necessarily anything about people itself.
Awesome. And since you're a computer scientist, I think this would pertain a little bit more. There's someone who has loved coding in Java for some time, and would you recommend them to minor or double major in computer science or data and analytics?
Yeah. Okay. So double major in computer science board. So I think the question can be read two ways actually. Can you major in both, or you should major in computer science, one of the two, if I had to pick one? So I would say if you can do it and you can major in something when you then move into medicine, the impact you'll have is insane. Because we need so much more of this technical know-how, right? And I think it's such an exciting time because there is so much change in medicine around this right now. Whether you should major in computer science or data analytics, I mean, it's up to you. I personally, I've become much more data person. I started much more as a digital health person, and then I kind of had this phase where I was doing much more root programming. So I think it depends on what you're interested in, but fundamentally they're all kind of the same, right? In the sense of when you have a system, you have much of data, and then you have to find a way to process data, and you have to create systems to do that. So I think whatever makes you happiest, and just do things that are interesting and impactful.
Awesome. So, with the talk of like a lot of AI in media recently, someone asked, are there concerns that AI would come with replacement of certain medical jobs? So, for example, there was talk about radiology being perhaps taken over by AI, or AI being more involved with that in the near future.
I actually have a very, I get this question a lot. I have a very different approach to this question of, I think about impact, right? So jobs are fundamentally about need and what we need, and do you need people to do this? And then I think about how many people have access. Because if they have access and they demand something, then you're needed, right? And then you have a job. So what happens in the future with jobs? It's unclear to me. I don't know. I'm not an economist. But what I can say is that if you take the tool of AI machine learning, and or let's say even a computer system like an EMR, in theory, you could replace doctors and computers in theory, but we know that it was never the case, right? We see use computers every single day. You never replace doctors. You just make doctors more efficient. Doctors on rounds no longer have to memorize the potassium level of every single patient to make sure that we're not missing something and write down manually all the lab values and blood pressures in the morning. We just glance at it real quick on the computer system and round very briefly. Whereas before you needed 10 people to collect all the data and interns and residents, and it would be much more painful work. I think we do much more interesting work because now we can think more deeply about patients to provide better care. That to me is a much more interesting approach to medicine. And frankly, I think that creates jobs because now you have so much more need. And because you have more need, you have more people that can fulfill that. And we just do more interesting things that are closer to true clinical care, like taking care of people and spending time with them, rather than the rote needs of documenting and clicking buttons and the things that have been, I think, such a large driver of things like burnout in medicine.
I think that's a very relieving approach to hear, because of whenever there's talk about AI, there's always concern with replacement of any type of job. And since we're talking about AI, Bryce, do you think as for most of the people in the audience, as aspiring medical professional, they should get involved with AI and coding in some capacity before going to medical school, or
I mean, I'm a little bit biased on this one, but I love that. I think it's one of the biggest areas that students can make an impact, because there's such a high need, right? If a young student is coming to me and says, volunteer, and I know medicine, a little bit of medicine, and I work in the hospital, that's nice, but it's hard to work with you because it's like, well, I'll see you in like 10 years when you're a physician and we can work together and your specialty. But if a young student says, I know how to program and I'll take care of this program for you, and then we can now analyze all the sepsis prediction patients, like, wow, you've made a pretty huge impact. So I've always thought about my career and in terms of like the things I spend my time on is how can I make a difference, right? If I can make a difference, then it's a good thing to do. And that truly has been the guiding light, that has been the how I've made my decisions, and that has always paid off well for me.
It's really nice to hear. And then they're talking about more research and getting involved with students who are actually involved in with AI work. There is someone who's currently researching drug development for Parkinson's disease using machine and deep learning. And while using mainly computational methods for research hurt them in contrast to having experimental research such as just wet lab.
Yeah, so I worked in a wet lab when I was a med student, and actually an undergraduate too. We were doing biophysics, so it's like we were looking at lysosomes and how they, with apoptosis to measure like the number of cell deaths and the proteins that would leak, and therefore but it was so computational in the end because you would still put all those charts into like a little bit of computers and then publish them. But we just had much smaller data numbers, right? So what I say is that it depends on a little bit on the area. If you're doing research in, I don't know, what's like a very basic wet lab question, rodent models of ischemia, potentially. But I would say that in almost every field that I've seen now, and I work with a lot of labs, it's all computational. Like almost every lab is becoming computational in some way. So, I mean, I don't sit on any emissions. I don't sit on the emissions committee, but I can't imagine it would be harmful to be able to be computational, and that's where I see most of medicine going as well. If you look at our board exams, they're much more about statistics and population health and these kind of numerical approaches to medical problems.
Exciting. And this is a very specific question to an individual. So do you utilize TensorFlow or PyTorch more for your personal projects like your would you research? Which workflow do you see having a greater application in healthcare?
Yeah, I used to use TensorFlow a little bit. I never got super into it. PyTorch is great. Python is amazing. I love it. Academics use R a lot. I love Python, actually. I think it's much more applicable generally. So yes, absolutely. And sorry, the last part of the question was, do you use them and?
Oh, it's which workflow do you see?
Oh,
being more greater application.
I guess I'm aging myself a little bit, but like I used to not use GitHub. Like now I'm just like a dinosaur now, and that was like so I'm a little bit of a dinosaur in this way too. I try not to keep up with the newest things because I've seen a lot come and go. C plus and C sharp and Java is all great. But I'm like a little bit of like I'm pretty conservative on this one. Like I try not to get too new and just use stable frameworks that have been around for a long time.
Oh, and then talking about programming languages, what programming language do you think is the most effective or most productive for AI development? And is there pros and cons to that type of, it's a very loaded question, pros and cons to that type of programming? And then we can answer the second half.
Yeah, this is a great question. This is like a very complicated question. So I like Python. I think, if you look at like Palm and these like amazing models that I am not up to date on, like I'm still trying to keep up because it's moving so fast. I think you can access them all through Python, and basically whatever you use on Hugging Face these days is the greatest thing ever. So if you're on Hugging Face and if you don't know what Hugging Face is, I know that's really random that I'm saying that, but it's a amazing website to learn on all and to see all the new deployments on language models. So I'm pretty sure they can all mostly use Python, and that's what I've seen. But I don't know. I'm seeing a little bit of where things settle out in terms of the entire landscape.
Awesome. And do you think that like a certain type of programming language restrict AI to biased logic rather than thinking outside of the box?
Potentially. I think it's like I think most programming still is one-to-one logical programming, right? So that's exactly what I was talking about. Is that I think it's so interesting that we're moving away from logic programming, which is very weird, to more natural language processing, which is more human and natural sciences and much more inquiry based, which is probably a better way to go about asking questions, right? It's asking questions and then trying to get answers. So it seems to me like the right approach. How actual language themselves evolve, I don't quite know. I think it will evolve with just time, but how that landscape evolves, I'm not sure.
Awesome. And because people are interested in getting in AI, getting involved, for someone who's like a beginner, what coursework experience or like certificates would you recommend for someone who's like never been exposed to AI but would like to be exposed to AI to get involved in and make an impact?
So I'm really biased on this. I run a master's program for healthcare data analytics at the hospital because the hospital has really needed this stuff. The biggest bottleneck in where I work in either data science or emergency medicine or the digital health center or any of these things is really just enough technical talent that can think clinically and understand like ICD-9 codes and all the applications of medicine that are really important. then teach them the coding skills or whatever the technical skills you might need. It's been harder to teach true, just pure coders the medical stuff, because the medical stuff takes years and years. So have found that people who come in with either a master's for a year or even short certificates can do really well, because if they have any sort of healthcare, biology, chemistry background, even having some of that, I think more technical experience can be extremely useful already with relatively low bar for success.
That's so relieving to hear, having that background, because I'm pretty sure a lot of audience members are in the science field. So it's good to hear that's coming into use. And you mentioned working in a biophysics lab in undergrad. So did you ever perform molecular dynamics simulations in the biophysics labs? And do you think it's a viable method for research?
Okay, so that's really interesting. We didn't do any of this stuff because it was too early. I'm a too big a dinosaur. So back then it was all very paper-based, and we didn't do this stuff. Today, there's no way the stuff I was doing would not survive without any sort of simulation-based work. So absolutely, it is really fascinating. And I think, models, this is a philosophical question, is models true? Models tell you about the world is true. So I think I'm a firm believer that humans create models, and models are useful as the person that creates it, right? It's not a perfect approximation of reality, but it can tell you a lot about reality. So it's useful, and sometimes not useful, depending on how you ask the question and what kind of model you make. So.
Perfect. I know we touched on about kind of like coursework and background, but is there a project you think that people who are in undergrad who want to get involved in AI should get into, like beyond side just coursework or the technical knowledge they have coming in from that?
So I'll give you an example. Is our lab takes a lot of undergrads, and certainly, anyone who wants to reach out to me, feel free to reach out to me. We always, I love working with students, especially ones who have a lot of energy and excitement. I would say that anything that interests you is fantastic. Any sort of technical skill set we can use. My recommendation here is just looking at publications, right? So I had a mentor when I was a med student, and he sat me down. He was like, "Listen, Shuhan, there's two ways you can do research. Okay, research one is you will have an amazing position at NIH, and it'll be your long fellowship, and you will, if you discover this thing about the lysosomal dynamics, it'll be the most amazing publication ever, and you'll land in Nature, and it'll be the greatest thing. But if you spread your eggs a little bit, you can potentially get lots of smaller ones, and some will work out and some won't, and that's okay. But I think that the second one is generally a better approach, because research is very stop and go. It's hard to know what works and what doesn't. That's true science, right? If I told you this is going to work 100%, you should be a little suspicious. This is real science, right? So I think that the multi-disciplinary approach of taking multiple projects, small projects and small bets, is often better, because you can then over time tease out which ones are going to work out and which one won't. And what's nice is that oftentimes you can get publications and small abstracts and conferences that can basically make your CV look really good. And because if you have that one paper and someone is flipping back the page and they just don't see it, you're in a little trouble, right? So having those multiple lines sometimes can be very simple and very nice, because then you can show that you're really involved in the scientific process and understanding how kind of the process works. So I generally tell people to get involved in kind of multiple things at once, and then kind of go from there.
Yeah, awesome. And to be mindful of time, I know time is flying by as we're going through these Q&A questions. I think we have room for one more question. So you mentioned ChatGPT, and it's obviously its relationship in academia. So I think it's interesting that you talk about using ChatGPT, and how do you think we can manage that balance of using ChatGPT, but not authentic, because there's a question of it not being authentic if you're using AI to type out your essay, and then you end up just using that to be more efficient, I guess.
Yeah. I mean, I always encourage people to say school and college and essays are nice, but really we're trying to do something with our lives, right? And make an impact. And so sure, we can all if there's an essay and you have to turn in and you're using it to turn in, sure, that's great. But what did you learn from that, right? Did you take home that, you learn something more about the world, and then are you able to argue against yourself and actually think about the problem from first principles and deeply? And that, I think, is always the most important concept of being able to not only have to write out the argument that you're trying to make, but let's say write out the argument against the argument against the argument against the argument, and really think about where you come in on this and think deeply, because that's how you discover innovation, by thinking out first principles and kind of the next step and predictions of things, if you kind of know where things really are occurring. So I think that's really interesting, right? I don't know policies I'm actually really curious on, like, what are policies now as or undergraduates or graduate students? What is the policy around this? Have schools come out with or for this? I'd be really curious to see what we've seen.
Yeah, so touch up. Thank you for answering our last Q&A. That was a really unique approach. But I think, at my undergraduate, and I think at most undergraduate like colleges, universities, they do prevent you from using ChatGPT because there is a feeling of it being not authentic. And so that was why the question was brought up. I think there's a concern that you're just using it, like not really using your own mind to think about the things you learned in class and how you can apply it, rather using like a third party to do that. So that's how it is, I guess, how it is in university so far. But again, thank you so much for all the amazing questions from everyone, because we had such amazing, unique questions about AI, such a relevant topic in not just healthcare, but in society. And thank you so much, Dr. He, for delivering an amazing presentation on a very unique approach to how we should view AI. And that concludes all our speaker sessions for the second day of the National Pre-Health Conference. So please, everyone, make your way to the closing remarks by leaving this webinar and joining that from the lobby. All right. Thank you, Dr. He.